there. So we've accumulated a bunch of rules up to the chain rule now. So let's do a quick summary of the rules that we know so far. If we take the derivative with respect to x of some constant, the derivative is 0. Derivative with respect to x of something simple like x itself is 1. Then we have some more generic ones like derivative with respect to x of c times whatever is equal to, we can pull that constant out, c times the derivative of that function. And the derivative is often abbreviated as f prime of x, right? So two kinds of notation we have to get used to. We have our sum and difference rules. That if we have one function plus or minus another function, then we get the derivatives plus or minus. And we have our sum and product rules, or sorry, our product and quotient rules. We multiply two functions together. Derivative of the first, so it's not as simple as the sum, times the second, plus the first, times the derivative of the second. So that's a super important one there. And similarly, the quotient version of that, which looks a lot like it, with two slight twists. Hopefully you've got these systems memorized. So like above, it's called the top one, the first function, times the second, the bottom. And then it's a minus, and the minus has to go with the derivative of the bottom function. All over the bottom function squared. We have the power rule, which originally looked like this. But now I'm going to state a new version of this, the chain rule version of this. So if we apply the chain rule with another function here, then the derivative of some function to a power is equal to, we apply the power rule, so we're going to get n times that function, but we reduce the power, and then the chain rule says you leave f of x alone here first, but then you have to adjust by multiplying by its derivative. And so this is the chain rule combined with the power rule. And so this is something that's super helpful, and this is going to apply to that question that was just asked about. So that's a twist on some rules we already know, and so the general chain rule, let's put that up here, is you have an outer function f and an inner function g, so we have the composition of two functions, then we take the derivative of the outer, leave its inside alone, and the chain rule says adjust by multiplying by the derivative of the outer function. So this is what we're working on in this section right here. Super important, probably the most powerful rule we've found so far. We're going to look at, in the next two sections, we're going to get a couple of equally powerful rules. Because there is still some functions we're not going to be able to take the derivative of, even with all of these accumulated rules so far. There's a couple of others I didn't mention here, some side ones, so I'm just going to throw those in here. We can fit them on one page. This was gone over back in section 3.2. We did a couple versions of it in class. the derivative of the square root of x is 1 over twice the square root of x. So that's one that's worth memorizing, and we're going to use that fact today. That was proved in class with the limit of the difference quotient and 3.2. They go over that also. So that's a nice one to put in your memory bank there. Another nice one that we've proved a couple of times, and I alluded that it's related to the chain rule, both of these are, is the derivative of 1 over x. You can think about that as x to the negative 1. And the derivative is, you could view it in two different ways. In this version, you could say it's negative 1 times x to the negative 2, thinking about that power rule there. But if you put it back as a reciprocal function, then it would be negative 1 over x squared. So depending on the power, sometimes the power rule here reduces the power, but if n was already negative, right, now it's a little more complicated than it was before. So sometimes derivatives are simpler than the original function, like here and here and here, but sometimes they're a little more complicated, like this one and that one. So it just depends on the original function. So we've actually gone over a lot more than that, but this, I think, are the in a nutshell, what we've done so far with respect to derivatives. So I would definitely recommend making yourself like a cheat sheet of all these important facts that we've accumulated.